Welcome, amazing friends, and let's solve this challenge on radical equation. I tell you, it's just very simple. And at the end, we are going to check. I'm going to teach you how to check to know if your answer at the left is equal to what you have at the right. It's going to be amazing. And don't forget to tell us how you feel about this in the comments. Let's do it together. So we're going to begin this with solution, okay? So we're going to have solution. Now, what do you do first? When you look at this is your radical equation because of this radical sign, okay? And when you see this radical sign, it just represents square root. So what do you do? Each time you have square root, to remove it, you square. Now, let's do it together. So we're going to now have 5 to the power of 8 plus 5 to the power of 2x divided by 5 to the power of 2x plus 1. Remember, there is square root there, okay? Then is equal to 25. So we want to remove the square root, and if you do that, you are going to square. So you are squaring the left side, you also square the right side so that the equation will be balanced. Now what do you do next? This is leading us to, so we're going to now have this square takes off the square root, you see. So we're going to have 5 to the power of 8 plus 5 to the power of 2x divided by 5 to the power of 2x plus 1, okay, is equal to, now 25 raised to power 2 is 25 multiplied by itself. Did you see that? And remember that 25 is 5 times 5, okay, and this is also 5 times 5. So you see, we are having 5 4, and that is the same as 5 raised to power 4. So we're going to have 5 to the power of 4. Did you see what we're doing? Now what do you do next? This is leading us to, so we're going to now have, we can make this to be in fraction by dividing by 1, okay? So we can easily cross multiply. So 1 we multiply everything at the numerator. So 1 multiplies any number, gives you back that number. So we're having 5 raised to power 8 plus 5 to the power of 2x is equal to, then 5 raised to power 4, we multiply the denominator, and that is giving us 5 raised to power 4 into 5 to the power of 2x plus 1. Did you see that? So what do you do next? This is giving us 5 to the power of 8 plus 5 to the power of 2x is equal to, now when you have something like this, you're going to use this value to expand the bracket. So this 5 will multiply this and will also multiply 1. Did you see? So 5 to the power of 4 multiplies this. We have 5 to the power of 4 multiplying 5 to the power of 2x. I hope you are seeing it. Then this will multiply 1. And when you multiply this by 1, it gives you back 5 to the power of 4. You see what we have? Now, at this point, what do you think we should do? What we are going to do here is we are going to collect those ones that have x together. Okay, so we collect like terms. Now, let's do it together. So for the like terms, we are having 5 to the power of, remember, we're going to remove this. Okay, so to remove this is positive, it is turning to negative, okay? And in that case, you bring down 5 to the power of 2x. I hope you are seeing it. Okay, now this is positive here, okay? So you are going to remove it and it becomes what? Negative. So you're having negative 5 to the power of 4 multiply 5 to the power of 2x. You see what we're doing? Then bring down your equal sign. You observe that when you remove this by subtracting, you are going to have negative 5 to the power of 4. So this is the same as 5 raised to power 4 minus 5 to the power of 8. Interesting. Now looking at the left side, quickly observe that 5 to the power of 2x is repeated. So you factor out. So to do that, you are going to have 5 to the power of 2x, open a bracket. Now use this to divide this, okay? And you know, when you divide a number by itself, it gives you 1. Did you see that? So we're going to have 1 here. Bring down this subtraction sign. Now what do you do next? This is this, okay? So you divide 5.5 to the power of 2x, divide it by this. Did you see that? And this takes off this. I hope you are seeing it. So we're left with 5 to the power of 4, okay? So this gives us 5 to the power of 4 is equal to, we are having 5 to the power of 4 minus 5 to the power of 8. Now, what do you do at this point? Just observe that, looking at this, there is the possibility of changing 5 to the power of 8 to be in the same with 5 to the power of 4. Let's see to that. Now remember this. If you have a to the power of m, raise it to the power of n according to your rule of exponents, it is the same as a to the power of m multiplied by n. Did you see that? Now, of what use will this be to us? If you look at 5 to the power of 8, you observe that 5 to the power of 8 can be expressed as 5 to the power of 4 raised to the power of 2. Did you see? Because when you multiply 4 by 2, according to this rule, it gives you back 8. I hope you are seeing it. So what it means is that to simplify this, it can still be written as 5 to the power of 2x into 1 minus 5 to the power of 4 is equal to 5 to the power of 4 minus 5 to the power of 8. Sorry, minus 5 to the power of 4, then raised to the power of 2. Interesting. So what do we still do? I'm going to show you. So this is giving us 5 to the power of 2x into 1 minus 5 to the power of 4 is equal to 5 to the power of 4, okay, minus, when you have something raised to power 2, it means that is expressed twice. So we have minus 5 to the power of 4 multiplied by 5 to the power of 4. Did you see it? So this gives us, we now have 5 to the power of 2x into 1 minus 5 to the power of 4 is equal to, you observe now that this is common, okay? So you just bring one out, open a bracket, use this to divide itself, it gives you 1, okay? Minus, then when you have 5 to the power of 4 multiplied by this, when you divide by 5 to the power of 4, it returns 5 to the power of 4. Did you see that? I hope you're observing something. You observe that this is common in both parts. So to remove it, divide both sides by 1 minus 5 to the power of 4. Divide this by 1 minus 5 to the power of 4. This takes off this and this takes off this. So we're going to now have 5 to the power of 2x is equal to 5 to the power of 4. And remember, according to your exponent, the bases are the same. Automatically, the power should be equal. And that takes us to the next step. So we have 2x is equal to 4. To get x, divide both sides by 2. And if you do that, x is going to give you 2. So the value of x for this radical equation is 2. Now let's do a check. To check, we are going to have, we now have square root of 5 to the power of 8 plus, for this we have 5 to the power of, our x is 2. So it's going to be 2 multiplied by 2. When you multiply 2 by 2, it gives you 4. Did you see? So we are going to have 4 here. Okay, so we have 4. Divide it by 5 to the power of, this will still give us 4. Okay, plus 1. Is it equal to 25? Let's see to that. Now, what do we do next? We are simplifying. So to simplify further, we're going to have square root of, now remember we said that this can be still rewritten as 5 to the power of 4 multiplied by 5 to the power of 4, okay? Then plus 5 to the power of 4, okay? Then you divide it by 5 to the power of 4 plus 1. Is it the same thing as 25? If you simplify, you are having, factor this out. So we have square root of 5 to the power of 4 into, when this divides this, you'll be left with 1. Then plus, when this divides itself, you have 1, okay? Divided by 5 to the power of 4 plus 1. Is it equal to 25? At this point, you can cancel this out. So you are left with 5 to the square root of 5 to the power of 4. Is it the same thing as 25? Now, 5 to the power of 4 simply means 5 multiplied 4 times. And when you multiply 5 4 times, it gives you 625. So 600, square root of 625, as you know, gives you 25. And 25 is equal to what we have at the right side. So it means that the value of x being 2 is what is correct. And I hope you learned a lot. Let's know how much in the comment, and don't forget to share for more people to learn the skills with you. Remember to give this tutorial a thumbs up, share with your friends and colleagues, I'll see you in our next class to tell you more. Till then, bye.